Alrighty, so again, extra credit is due today. If you have that to turn in, that's great. I did not, I apologize right from the start, I only got half of your tests corrected. So I got Form A corrected. I went and saw Lucas this weekend, so I didn't have the weekend. I intentionally didn't take them along with me so that I could focus on first time dad visiting college ed or visiting kid at college. So, and then last night I was busy also because I went to go watch Claire Kalniss play softball last night in Madison, so didn't have a chance. So there's that. So I'll get those into the grade book very shortly. I should have time today to finish up grading those and get those done and turned in. Or, put in the grade book. So there's that. We did update the calendar in the back. So that it takes care of all the way up to and including basically through our next break, because remember Thursday and Friday, the 23rd and 24th, you guys are off. 23rd is a in-service day, professional development day for teachers, and 24th is a day off for everyone in the district. So, so that's kind of like your fall break type one. So we will be testing on a Tuesday this unit, just so you are aware.
Is the 22nd like a half day because of your conference?
Yes, it is. Yes, and so really, it's not going to be sign and soil kitchen sink there, but we're going to sign a soil kitchen sink then on the Tuesday coming back. So yeah, so there's that. Yeah. Meaning so the next unit we're going to deal with sines and cosines and transformations of those and graphing those transformations. And so there's 4 different transformations that happen on each one of those. And so the first day, we were thinking that day, and then we remembered too, after we made it, that it's only a half day, so Schmeling doesn't meet that day. So we were going to throw all 4 transformations at you on that day and say, here we go. Just short. Yeah, just short, but we'll still have them. So, yeah. Yep. So, all right. I'm trying to think of anything else. If there's any, if there's time, I do have like all the homeworks and all that stuff to hand back to you today. If we get to it, if we don't, we don't, because the important one's not there. So, when you came in today, you should have picked up a white note packet. So we printed out. There's a lot of like triangles and stuff in this one. So we printed you out a note packet for this unit. So that is where you'll have your notes today. And then the brown one is your homework packet, which will be due on the 21st. And again, just as a pacing, if you will, in terms of your homework packet, in the back in red on after each day, we put where you should be at in terms of the homework packet. We didn't go with numbers this time because when we printed it up, we took it out of the box. We realized that this was the last one that we didn't go 1 through. I think it ended up being, because we switched it then yesterday. I think it's like 1 through 140 or something like that. So there's 140 questions in it. But JJ, don't freak out, because a lot of them are 5-second problems. Because if you'll notice, tomorrow's unit circle day. Okay, so tomorrow we develop the unit circle again. Okay, all right, here we go. That's 4 minutes and 9 seconds of rambling. That's not bad. All right, so we'll start at the start. It's Special Right Triangles Day. Okay, so there are 2 special right triangles out there in this world. The first one is an isosceles right triangle, or a right isosceles triangle. And that triangle has 45-degree angles to go along with it. Because if you remember from geometry, you guys are, no, next year's the last one that I could say if you remember from geometry. If you remember from geometry, an isosceles triangle has congruent base angles. Okay, so that's why they're both 45 degrees, because the sides are the same. So then, if I were to run our old friend, the Pythagorean theorem, on this, to try and find the length of that hypotenuse, okay? Remember, legs are the two shorter sides, in this case, the other two sides, and then the hypotenuse is the longest side. So if I was to run the Pythagorean theorem on this, I would get x squared plus x squared equals this red box squared. Okay? If you have one pencil and your friend gives you another pencil, how many pencils do you have? Two. You got 2 pencils. Did they miraculously change into whiteboard markers? No, still pencils, right? So x squared plus x squared is 2x squared. And so that's going to still equal my missing side squared. How am I going to solve it now? Square it. Square root, not divide by 2. No. I'm going to square root both sides. Yes, I'm going to take the square root of both sides. So I'll deal with the easy side first. First off, I'm going to fix this 2. There we go. Right side, red box squared, then square root of it. What would it become? Just a red box, right? Okay. So we would just get here just a red box. Okay. 2x squared, square root of that. No. Because we break this up, right? So we would break this up, so the square root of 2x squared is really the square root of 2 times the square root of x squared. Agree with me on that? Square root of 2, can we do anything with that? No. Square root of x squared. What's that? That's just x. So we would write this as x square roots of 2. Okay. Now, that is important because did we set the length of side x? No. So we could put any number in for x, and that would be true. So for instance, if I said that the side lengths of my right triangle were 15, then the hypotenuse would be 15 square roots of 2. If my side lengths are 4, my hypotenuse is 4 square roots of 2. If my side lengths are 3 halves, then my hypotenuse is 3 halves times the square root of 2, or 3 square roots of 2 all over 2. Okay, so that part doesn't matter. Okay? So now let's work this in reverse, because you should really memorize this one. Now, let's say that my hypotenuse is 1. My side lengths, then, would still be x and x. Right? So we'd still have this. We'd still have x squared plus x squared equals 1 squared now. So we could follow this same logic and we could pick it up here at x square roots of 2 equals 1. So what would x be equal to? 1 over the square root of 2. Now in maths, okay, because I would divide here by the square root of 2, I would divide by the square root of 2, and so we'd get here x equals 1 over the square root of 2. But in maths, we don't like, especially on the unit circle, we don't like radicals in our basements. So we have to do what's called rationalizing the denominator. So I'm going to take this and I'm going to multiply it by the square root of 2 over the square root of 2. Okay? That purple fraction, what's it really equal to? 1. And when I multiply by 1, I don't change the fraction. Okay? Exactly. Yes, you are correct. X here is equal to the square root of 2 over 2. And so then that would become my length of the two sides. Okay. Good times. The other special right triangle is a 30, 60, 90 right triangle. Schmeling was trying to remember what he meant by DSF, and he couldn't figure it out again. So he forgot what it was, and then of course I went back and looked at our notes. Don't have it written down. Of course, why would we write down what DSF means, but just Schmeling being Schmeling. Yep. Okay. All right. So in this 30, 60, 90 triangle, okay, there's a couple of things to remember. The first one is that if this side length is x, then the hypotenuse would be 2x. Okay? In a 30, 60, 90, the hypotenuse is twice the short leg. Okay? Now, I could do the Pythagorean theorem for you if you wanted to, but what it really boils down to is this other side here is x times the square root of 3. Okay? And we refer to them as short leg, long leg, and hypotenuse. Okay? So the short leg sets the other two. So the hypotenuse then is twice the short leg, and the long leg is the square root of 3 times the short leg. So again, if I bring it back to now my hypotenuse is 1, if that's the case, okay, so 1 is equal to twice the short leg. So what would the short leg then be? 1/2. If the short leg is 1/2, then the long leg would be 1/2 times the square root of 3, which we write then as the square root of 3 over 2. Okay? Remember, in a triangle, the longer leg is always across, opposite in the triangle from the biggest angle. Okay? Smaller legs are opposite smaller angles. Okay? Any questions so far? Love it. Okay? So, let's talk about the unit circle. Okay? Now, a few years back, we pushed down some right triangle trig and unit circle trig into Algebra 2. So a lot of you have this information already. We teach it just a little bit differently. Okay? So first off, just a reminder that the unit circle, the equation of the unit circle is x squared plus y squared equals 1. Okay? Which is the equation of a circle centered at the origin with a radius of 1. Okay? Which means then that this point out here is the point 1, 0. This point up here is the point 0, 1. This point over here is the point -1, 0. And this point down here is the point 0, -1. Okay? Each and every t value or a wrap value. Now, here is what we mean by that. Okay? So if we're thinking in terms of radians and radiuses, or radii, if you will. So we're thinking in terms of radian. A wrap value would be the amount of distance that I have to go on the unit circle to get a central angle of t radians. With me? So if my t value is 1, in terms of 1 radian, on the circle, that wrap value is the same length as 1 radius. Okay? We talked a little bit about it, but we're tweaking how we're saying it in this unit. Okay? So each t value also corresponds to a central angle whose radian measure is t radians. Okay? If that's the case, and I'm on the unit circle, then the end point here is going to be a point x, y, right? And the following 6 things are all true. Because, bless you, because we are on the unit circle and our radius is 1. The first thing that's true is that the cosine value of that, or the cosine of t, is equal to the x value at that point. The sine value of t, now I say this every year, it's not sin. Okay? It's shortened to sin, but you still pronounce it sine. Just like this is not cos. Okay? It's cosine. Okay? So the sine value of t is going to be y. I don't know why I made my y goofy. Because I probably almost wrote a t there. Okay? The secant of t, yes, we will get into the secant of t, is 1 over the cosine of t, so that would be 1 over x. Everything needs a co. I can't stress this enough. Everything needs a co. Cosine goes with secant. Sine goes with cosecant. Everything needs a co. Okay? You can't have 2 cos. Everything needs one. So cosecant, or CSC of t, is 1 over the sine of t, which is 1 over y. The tangent, not tan, the tangent of t is going to be the sine divided by the cosine or y over x. The cotangent, not cot, oops, I put y there, 1 over the tangent of t is going to be x over y. I'll give you a moment to let that sink in. So, my question to you is this really possible? Is this really a possible point on the unit circle? And if it is, find all 6 trig values for it. It's up there. I see it. Okay? It's up there. I see it. Okay? It's at the top of the next page. It's there. Fear not. So if I need to know that it's a point on the unit circle, then it has to fit the equation x squared plus y squared equals 1. Because that's the equation of the unit circle. Okay? So that would be negative 5/13 squared plus negative 12/13 squared would have to equal 1. Negative 5/13. Listen, these numbers are so small, we don't need no stinking calculators for this one. Negative 5/13 squared. What's negative 5 squared? 25. What's 13 squared? 169. Negative 12 squared? 144. 13 squared? 169 again. Does that help us? Because we've got common denominators already, right? That's a good thing. Okay. All right. So 25 plus 144. $25 plus 144, 169. So this becomes 169 over 169, which is 1 equaling 1. So is it on the unit circle? Yes, it's on the unit circle. So then it asks me to find the 6 trig values that it is. And I can do that now because that on the last page there, where we said cosine was equal to x, sine was equal to y, cosecant was equal to 1 over x, secant was equal, I like 1 over y, secant was equal to 1 over x, tangent was equal to y over x, and cotangent was x over y. That only works on the unit circle. Okay? So now that we know that we're on the unit circle, now I can say that the cosine of t is equal to negative 5/13.
How do you know the pick?
What do you mean? Because it's the x value in my point. Remember?
Yeah.
I can go back if you need me to.
No.
Okay? Which means then that the sine value is negative 12 over 13. Right? Which means then that the secant value, what's my secant value? Negative 13 over 5. I just reciprocated. What's my cosecant value?
Wait, how is it?
Negative 13 over 12. Talk to me.
How did we get?
Because remember when I said that secant was the reciprocal of cosine?
Yeah.
Remember when I said that? 1 over x?
Oh yeah.
Right? So we just flip it. Yep.
Yeah, but when it one
I mean, if you want to, you can do this. You 100% always have this option of doing more math. So it'd be 1 over negative 5/13, right? Right? But what do I do when I'm dividing by fractions? Say loud. Keep, change, flip. So I would make this be 1 times negative 13/5, which is going to be negative 13/5. Okay? Yep. With me on that so far? Okay. Tangent. Well, now I got to come over here because tangent is y divided by x. Keep, change, flip again, right? So that's going to be negative 12/13 times negative 13/5. Negative times a negative is a positive, so those go away. I got a 13 on the top, I got a 13 on the bottom, so that leaves me with 12/5. Which means my cotangent then would be 5/12. Lay it on me. So the question was, how does this answer the question? So this right here is the answer to that question. Is this point on the unit circle? Just tap the brakes. Okay? So that answered that question. And I said we have to do this because these relationships only work on the unit circle. Okay? So we had to prove first that it was on the unit circle. Okay? Then it said, if so, find me the 6 trig values of t. So because it was on the unit circle, then cosine is equal to the x value of the point that we're at. Sine is equal to the y value of the point that we're at. Tangent is equal to y divided by x. Secant is equal to 1 over x. Cosecant 1 over y. Cotangent x over y. So in answer to your question, we had to answer that question after we found out that it was on. Now, if this one turned out to be something goofy like 180 over 169, where it's not then on the unit circle, then we can't find these 6 because it's not on the unit circle. Okay?
You would write that as an answer for that.
You would write the point is not on the unit circle. Yeah. Mm-hmm.
So like the numbers or the answer.
We're finding the values of so the cosine of that angle. If you were to type in your calculator, the cosine, if we knew what the angle was, okay, and you type in the cosine of this angle. Now let me draw in this angle for you. Here would be angle T. Okay? So we have to find that angle, and you type in on your calculator the cosine of that angle. Your answer that your calculator is going to give you is negative 5/13. If you type in the sine of that angle, your answer on your calculator is going to be negative 12/13. Okay. So we found the values of those 6 trig functions.
Are we going to be expected to memorize these six?
1,000 million%. Yep. Yep. The answer. The question was, do you have to memorize these 6? Yes, 100%. To the point that next week, Thursday, you're going to take a unit circle memory quiz. Okay? Meaning, we are going to ask you to reproduce that entire unit circle from memory, along with give me those 6. Okay? And yes, that is summative. Yep. Okay? That's next week, Thursday. Okay? Speaking of said unit circle, let's talk about the sweet 16 on the unit circle. Okay? So we'll get more into this today, but we'll get more into this tomorrow. But for right now, let's break down the 4 easiest of the points. Okay? So the first point that you have is right here. We said that was the point 1, 0. It is on the unit circle because it satisfies x squared plus y squared equals 1. Okay? In terms of degrees, this is the point 0 degrees. It is also the point, the trig measure here, or the radian, or not the radian, I'm getting ahead of myself. The degree measure is also 360 degrees. Okay. In terms of the radian measures, this would be 0 radians. It would also be 2 pi radians. So that's all the way around the circle. Okay? Halfway around the circle then would be this point over here, which would be the point negative 1, 0. Still satisfies x squared plus y squared equals 1. So it is on the unit circle. If all the way around the unit circle is 360 degrees, how many degrees is halfway around the circle then? 180 degrees. If all the way around the unit circle is 2 pi radians, halfway would be pi radians. Those 2 points are on the unit circle. Half of half. So a quarter of the way around the unit circle would be up here. This would be the point 0, positive 1. Half of half in terms of degrees would be 90 degrees. Half of half in terms of radians would be 1.5. Just half pi, right? So pi over 2. With me on that? We can go to the other half of the unit circle. That would be down here, and that would be the point 0, negative 1 there. So now I need the halfway point between 180 and 360. 270 degrees. I need the halfway point between 1 pi and 2 pi. 3 pi over 2 or 3 halves pi. Yep. That's it. Yeah. Any questions on how I got those? Tomorrow we will do the other 12 because we're going to develop them not just by giving them to you, but we're going to develop them by using special right triangles that we learned today. Okay? Right now, what I'm going to do is I'm going to stop. Okay? I'm going to hand a bunch of stuff back. While I'm handing stuff back, you can be working on page 1 of your homework packet, which I believe is both the front and the back of that page. Nope, I lied. Just the first page, just the front side of your homework packet.